Hey everyone, solving these by using completing the square. The last video here, and what we're going to do is we're going to talk about how we can use what we know about completing the square now to help us put an equation into vertex form. And that's helpful if you actually have to graph this, right? So you can actually use completing the square to help you write it in a form that makes it much easier to graph. And the reason it works so well, it really lends itself to this, is because completing the square by nature puts it in this x minus h form already. Because when you complete the square, normally you'll have this number over on the other side and it's equal to it. And then you have this. But all you got to do is, if you're writing this in a form where you have another variable, then you have that number over there anyway. And so you wind up with these two things. So it's a pretty, it's a smart concept. Some of the things that happen in math like this, I think, are really pretty cool, the way they work out so nicely and neatly. The only thing that you will need to really pay attention with this is when we are completing the square, we're going to do something a little slightly different with how we balance the equation because of that y. So let's just dive in. All right, so it says write the equation below in vertex form. All right, so in order to write the equation in vertex form, I have to have something that's in an x minus h form plus a k. And k can be 0, but I got to be able to write this in a squared binomial form. And you can see, looking at this equation, that it's not factorable, so I can't write it like that. So what we do, because we have this y here, is we're going to leave the y over there, and we're going to write this as x squared plus 2x. I'm going to leave a space here, and then I'm going to write plus 4. All right? So now the next thing I want to do is I want to figure out what do I need, what am I going to use here to make this into a square trinomial, at least this little bit right over here, right? Well, x squared plus 2x, my 2x is my middle term. I divide that by 2. So 2 divided by 2 gives me 1. And then if I square 1, 1 times 1 is 1. So I'm going to add 1 here. Now here's the thing. These are not, this whole thing and this are not on opposite sides of the equation anymore. They are on the same side of the equation. So because they are on the same side of the equation, I have to deal with balancing this slightly different. So what I'm going to do is I'm going to, instead of adding 1 over to this side, which I could do, mind you, I could go like that, right? But instead of doing that, what I'm going to do is I'm going to subtract it. And then if you look at this, it's kind of like, well, that's weird. You got plus 1 and you got minus 1, and they sort of cancel each other out. That's the idea, is they would cancel each other out if we weren't completing the square. So that's what you're going to want to do with these, is whatever you do in this little section of it right here to complete the square, you're going to undo it by doing the opposite of it further on in the equation. So let's finish writing this out now. So now we've got y is equal to x plus 1 squared because we completed it, right? And then you just simplify this. 4 minus 1 is 3. And here's the thing. If I break this out and I simplify this, it's going to get me back to this anyway. And that's how you can check your work and see it. But now it's written in vertex form. It's written in that x minus h squared plus k. So my vertex would be the point -1, because remember it's x minus h, and if it's a positive number here, that means it's a minus. And then plus k, so my k is 3, right? I don't know what that is. But so -1, 3. So that is how you write this in vertex form. Let's do another one. All right, so what I'm going to do first with this problem is I'm going to leave this y the way it is, and I'm going to factor a -1 out. And the reason I'm going to factor a -1 out is because you can't deal with a -1 when you're trying to do this. And the way I'm just going to factor it out of these two terms. All right, so I'm going to go -1 is going to give me x squared minus 2x, and I'm going to leave a space, and then I've got my -3 over here. Okay? So now you see how this becomes much easier to deal with. All right, so let's figure out, well, if I divide negative 2 by 2, I get negative 1. If I square that, that gives me 1. Now, this is where you need to be careful, is you might be like, well, if you got negative 1 there, that means, well, or if you have positive 1 here, right here, that means, oh, you're gonna offset it by doing that. But here's the thing with that that's tricky, is I do have 1 here, but this 1 is inside the parentheses that's being acted on by that negative 1. So I've added a negative 1 onto this equation by doing this. So in order to offset that, I have to actually add a positive 1. All right? And then we'll go through and we'll expand this one out so you can see what we did. All right? It's not really that confusing, but so you got y equals negative 1, and then x minus 1 squared, and then this would be minus 2. All right, so this would mean I would have a vertex of 1, negative 2, and because I have that negative 1 out here, it also means that this thing is going to be opening downward like that. All right, so real quick, let's expand this out and see if we wind up with our original equation, just to show you that this does work. So I got my negative 1, and then this is going to get me x squared minus 2x plus 1, and then I have my minus 2, and then this negative 1 basically is going to take this whole thing and change all the signs. All right, so minus 2 and minus 2. Okay. If I did this right. Oh, wait, I didn't do that right, did I? Nope, I made a mistake. So this would be minus 1. All right. So we're in good shape so far. And then we can combine these numbers. So we have y is equal to negative x squared plus 2x minus 3, which is exactly where we started. So the process might seem a little weird to you because now we're balancing on the same side of the equation. But just remember, whatever you do to one term, when you're on the same side of the equation, whatever you do to one term with your other terms, you just got to do the opposite to kind of offset it. So it's like, well, you take it away from here, then you got to add a little bit here. Well, if you add a little bit here, you got to take it away from the other side. So good luck with that. I think you'll do well, and enjoy the assignment.